Hi, welcome to my submission for the Kong AI Hackathon 2025. My name is Andrew Q and I'm the CTO of Q Innovations. My submission today is the Kong Auto Rollback AI agent. So to start off with, I thought it's probably worthwhile us just talking about the theme for this year's hackathon. So I went to a definition by one of the big players within the AI space, NVIDIA. And NVIDIA say that agentic AI is made up of 4 pillars. It's perceive, reason, act, and learn. So perceiving, it's gathering and interpreting data from different sources, sensors, databases, and extracting some meaningful thoughts from that data. It's then using large language models to reason from the data and understand the tasks and solutions that it needs to coordinate in order to solve whatever the task is that it's been given. It's then to act on those tasks. So through the use of APIs or external tools with some built-in guardrails, to ensure for some safe and accurate actions of those particular tasks. And then finally, learning. Having a continuous feedback loop to adapt and drive smarter decisions and greater efficiency moving forward as these tasks are continually executed over time. The problem space that my hackathon is looking to solve, I think, is a very real world problem. It's around the misconfiguration of the gateway and the effect that this has on an organization. So a misconfiguration can disrupt critical traffic in an organization. The mean time to resolution of fixing those can often be a lot larger and take a lot longer than expected. I think even these days with observability, so alerts and the metrics and logs, it can still take quite a long time to resolve and is still very reliant on human interaction. A SRE member has to get the alert. They then have to understand the alert, know where to go look at the logs, look at the metrics, work out what's going on. And in a very distributed organization, it could be in a different AWS account, or it could be in a different EKS cluster, for argument's sake. They then have to work that out and then maybe even bring in a team who's the team that owns that, right? They may only support the platforms. It's not necessarily their applications that are being run. The rollback procedures then can be very cumbersome and complex as well, right? And this what leads to that higher mean time to resolution. So we're looking at seeing how we can effectively automate these processes that are very human reliant. So what exactly does my AI agent do? So it's a SRE AI agent, which is Holmes GPT at the heart. It has been extended with 2 MCP servers, one being the Kong Connect MCP server and the second being Slack. Based on the prompt, it then looks and monitors for non-200 HTTP responses. It works out which API is failing and then looks to make the change to revert that misconfiguration. So let's have a little bit look at the architecture. So the architecture down at the bottom, very simply, is a Kong gateway that's connected to a Connect control plane. It's a simple consumer and upstream going through the gateway with some plugins configured at the gateway. The agentic AI part of it is in this red box. Again, like I said, Holmes GPT at the heart. It is linked to an LLM from Anthropic using Sonnet 4, which has been giving the best results. 2 MCP servers, as already mentioned, a Kong Connect MCP server and a Slack MCP server, and then some internal capabilities of being able to work with version control, so with Git, and in this demonstration or in this hackathon, I'm using GitHub. So How does all this get triggered? Well, we have a prompt that gets sent on a schedule, and that prompt then gets read by Holmes, sent to the LLM, and the agentic process moves forward. So having a little bit of a look into the tasks that Holmes and the LLM reason from the prompt. So this is an example of some of the tasks, and this is what you see in the logs, which we'll see as part of the demo. So the tasks that, as part of the investigation, is listing the control planes from Connect. It's querying the API request the last 15 minutes to identify non-200 errors, analyzing them to see and finding a 100% error rate. So this is a threshold that I've set as part of my prompt, and obviously you can change this to whatever you want. But in my mind, 100% error rate. So a change has been made and everything has stopped, right? What you don't want to do is, oh, there's one error, now I'm going to go and try rollback a configuration, right? Because errors do happen. So, but this is looking for total wipeout of your connectivity to those endpoints. If there are no issues found, it will send a summary to Slack. We'll have a look at that in a second. And if there are issues found, it'll check the GitHub repository for a YAML configuration, identify the problem configuration, create a PR, and send the details finding to a Slack channel. So now let's have a look at the demo of all of this. First thing worth calling out, I've got a Git repository that'll be part of this submission, and this effectively is the whole project. It is something you can use to sort of follow along and run it yourself locally or on a Kubernetes cluster in a cloud provider, and it gives you all the prerequisites. So, AWS Bedrock for the LLM, GitHub for your repository, Slack integration, Connect integration, and then effectively deploying a Kong gateway. I've got an install script to create that for you automatically in Connect. And then there's a very handy Helm chart as well as part of this repository to deploy everything to a Kubernetes cluster. Having a look at the configuration quickly, this is a repository that's linked to my data plane. I've got a single YAML here of configuration that has a Prometheus plugin, a simple service, and a root as well. So this is effectively what has been deployed to my data plane. I then also have two pipelines as part of GitHub Actions, a deploy and a governance one that just checks the configuration is, sort of a sane and acceptable configuration. And these will automatically deploy, which we'll see as we start making changes. Let's have a look at Slack quickly. So if we have a look at Slack, you can see I've had a few messages come through already, and this is effectively my agent running and not finding any issues, right? So you can see here that it's run and no roots have found with any error detection. Everything's fine. It's found my control plane. It's called AR Auto Rollback. That's in Connect. It's also found a root as well with a UUID, and yeah, all systems operating, nothing to worry about at this point. Have a look at my deployment. You can see here I've got Holmes, which is running as a pod, and my two MCP servers. And then I've got a cron running here. This cron currently is triggered every 30 minutes, but you would probably have this running a lot more regularly. This is just 30 minutes for this demo. That can be configured as part of the Helm chart as well. So if I just quickly run a watch hitting my endpoint, you can see I'm coming back with a success. So I'm hitting it and everything is working great, which I'm really happy about. So nothing's a problem at the moment. If I quickly have a look at Connect and just see what's going on here, you'll see, okay, I'm getting some successes coming through, and if I just quickly stop that and just have a look at the last hour, you'll see I'm getting some success and failures coming through. So yeah, it's, I've got some responses coming through, which is great. So 200 responses. So now what I'm going to do is I'm going to make a change to my configuration. So I'm a platform team. and I've decided what I want to do is make a change to my configuration, and I'm going to add a plugin. So in this case, I'm adding a request termination plugin. So add request termination plugin, and I'm going to commit that. What this will do is automatically kick off my action, and this action will run. And if I go into this and have a look, you'll see that it will run, and it will ping the gateway, make sure it exists, and then it will deploy the change across to that gateway. If I now come across and have a look, and I run my request to my data plane, you'll see I'm now getting a service unavailable. So that plugin has now been applied to my data plane, and I'm now getting failures coming through. So if I now switch across back to Connect and have a look at what's going on here, you'll start seeing, okay, my 200s have now gone down to 0, and I'm now getting my 500s coming through. So let's leave that running for a second and just get some data coming through. You know, one of the thresholds that I've got set as part of my prompt is to look for 100% failure rate. So if it's not 100%, then it's not going to trigger, which is what we want, right? What we don't want is one error come in and then everything stops working, because then you're going to have things reverting when it doesn't need to be reverting. So let's just have that come in with a few more errors, and then effectively what we will do is we will trigger that off. So I'm going to come here, and I'm going to come to my agent. I'm going to look at the logs, just make that full screen as well, and pull that down slightly. And then what I'm going to do is I'm going to trigger my cron job manually, just so that we've got it running and we don't have to wait for an extended period of time. What this will then do is it will trigger my agent with the prompt, so that's part of the control plane, and we'll be able to follow along and see the logs of what's going on as part of the tasks that Homes GPT has calculated. So let me just check. We've got a few more errors coming in. Okay, that's looking pretty good. Let's give that a kickoff and see how that goes. So run a trigger, and now let's have a look. This is kicked off, and let's see how it goes. Now, of course, if there haven't been enough errors coming through over the period of time, it's not going to trigger, and it's going to come back and say that there's no issues. So we may have to trigger this twice, but let's have a look and see effectively what it does. So you can see it's gone out and it's using the Connect MCP server, you know, and it's having a look. It's querying the API requests, and let's just see what it gets back, and then it will then analyze the failure rates based on what it got back. So let's see what it did. Okay, so it is now checking the details of the plugin. So now it's obviously found the failure rates, right? So it's now investigating the GitHub repository, and you can see here it's found my kong.yaml file. So it's now reading that, and it's working out what it's going to do. Oh, it's found the request termination plugin. This is great. It's going to remove the entire request termination plugin. Okay, lines 6 to 9, it's going to start working on that and start removing it. So leave it to start doing its work, removing it. It'll be creating, you can see here, creating a pull request. Yeah, so it's got a pull request. Let it finish doing its changes, and then it will finally send a request through to Slack, and we'll be able to see what it's come back with a link to the pull request. Now it's sending the results across to Slack. And there we go, tick, that's completed. So let's go across to Slack and see what happened. Okay, critical issue resolved, 100% error rate detected. It's got my control plane. It found my route as well. You can see it's even found the path to the route. It's found that there's some errors, and it's got a link to my pull request. It's got a list of all the tasks, and these are the same tasks that we saw in the logs, right? So I'm just going to copy this link and come back to my browser, and I'm going to open that up, and we have now got a pull request. So you can see even the title, fixed removing a failing request termination plugin causing 100% error rate. Let's have a look at the files changed. So you can see here, it's fully removed the request termination plugin. It worked out that that is where the problem was, and that is what it needed to do. If I come down to here as well, you can see then it also talks about what it did. It removed the request termination plugin, causing the 503 errors. I've then got a automatic check, and this checks the configuration. So it will make sure that the configuration that has been changed by the agent is still sane, right? It hasn't created an incompatible YAML file. And we can have a look at that, and you can have a look and see what it's running, but it uses the dec command to check that the configuration is a valid configuration. So now that this is done, I'm really happy with this change, and obviously I want to deploy it. So I'm going to merge this change, right? And I'm going to say that's absolutely fine, merge the change, and as before, come to my actions, and you'll see that that is currently running. So this is running like it was before. It will run and it will deploy to the gateway. I'm going to come across to here, and again, here's my gateway that's running, or my request that's running, and there we go. It is now gone, and my service is back up and running, and I've now got 200 responses coming back into my gateway. So there we go. My AI agent, it monitored the issue, it found the issue, it located the problem, it rolled back the problem, it created a pull request for me to at least analyze it and make sure it's okay, and then I can deploy it as part of my standard deployment practices. Quickly looking at to connect again, if we look here, we can now see my errors going down and my successes coming up, right? So we can see the changing of that coming through already. So everything, this is what you want to see, the errors going down and the successes coming up. So perfect, that's all done. So let's quickly jump back to my slides. So further improvements, obviously this being a hackathon, right? There are always improvements that we can do to whatever it is we've built. So the things that I would look at improving and what I've done, probably better Git integration. I want to look at it working more with Git tags. So rather than making a single change, maybe look at rolling back a particular version. If you are versioning your configurations, maybe doing a rollback of the version, so to the last known state, the last known version of your configuration, as well as looking at workflows. So having a look and seeing, did a workflow run in the last 5 or 10 minutes? And that is then evidence that a configuration has just been pushed that can cause it, rather than it just going in and making any changes. The next would be around AI governance. So there's not much governance that I've got here, but I would definitely look at better security and 100% more guardrails around what this is doing. At the moment, it is a bit too open, but I'll definitely look at using some kind of AI gateway to manage that. And the last one is probably improving on the learning feedback as well. So this whole continuous feedback to optimize what it's currently doing. And I think, that being one of the pillars that NVIDIA came back with, I think that would improve over time how this AI agent would run, and actually the decisions that it's making and how optimized it's actually working with those particular decisions. So thank you very much for your time. You can contact me with the QR code on the screen. I hope you all have a very good day.